All right, let's talk about one of the sneakiest and honestly most common threats you'll find online. It's called cross-site scripting, or XSS for short. Now, what makes this one so interesting is how it cleverly turns the very websites you trust against you. So how does that even work? Let's dive in.
So here's our game plan. First, we're going to unpack what XSS actually is and how it messes with that digital trust we all rely on. Then we'll get into the nitty-gritty, the anatomy of an attack. After that, we'll look at the three main flavors of XSS. And finally, we'll tie it all together to show you why this isn't just some abstract tech problem. It's a real-world risk.
Okay, so think about how you use the internet every single day. You go to your favorite sites, you log in, you comment, and you do it all with this unspoken layer of trust, right? You just assume that the code and the content that a website sends to your browser is, well, safe. But what happens when someone finds a crack in that foundation of trust?
And that's really the core question that XSS brings to the table. It's a vulnerability that completely weaponizes that trust. It takes a website you know and love and turns it into basically an unwitting accomplice for an attacker.
So, what are we actually talking about here? Well, at its heart, cross-site scripting is a security flaw that lets an attacker inject their own malicious code, we're usually talking about JavaScript, into a perfectly legitimate website. And the kicker is, that harmful code then gets delivered to other users and their browsers just run it, no questions asked.
Yeah, it really is the perfect middleman attack. The website itself isn't hacked, not in a way you might think. It's more like it's been tricked. It's been duped into becoming a delivery service for the attacker's malicious script. And here's the really clever part. Because your browser sees that script coming from a domain it trusts, say your bank or your go-to social media platform, it just assumes it's safe and executes the code.
Okay, so that's the what. Now for the how. How in the world does an attacker manage to sneak their code onto a website they don't control? Let's pull back the curtain and look at the anatomy of one of these attacks.
It all boils down to one thing, really. A website not being careful enough with the data it gets from users. I mean, think about it. You're constantly giving websites input, right? Search bars, comment boxes, your profile bio, all that stuff. If the website doesn't properly check or sanitize that input to make sure there's no sneaky code hidden inside, well, it's basically leaving the front door wide open for an attacker.
And the whole process plays out in about 3 key steps. First up, you have injection. The attacker finds one of those weak input fields and sticks their malicious script in there. Step 2 is delivery. The website, completely unaware, then stores or flex that script and serves it up to other visitors. And finally, step 3, execution. The victim's browser gets the script, sees it's from a trusted site, and just runs it. The website itself becomes the weapon.
Now, you should know that not all XSS attacks are created equal. They actually come in a few different flavors. We can group them into 3 main categories, and each one works a little differently and carries a different level of risk. So, let's get to know them.
So here's a quick look at the big 3. You've got stored XSS, which is persistent, it hangs around. Then there's reflected XSS, which is more of a one-off attack that needs you to click a link. And finally, the really stealthy one, DOM-based XSS, which happens entirely on your machine. Now let's dig into each of these a little more. First up, we have stored XSS. And honestly, this is usually considered the most damaging type. Why? Because the attacker's malicious script gets saved permanently on the website server, like in the database. Just imagine a script hidden in a forum post or user's profile bio. Now, every single person who visits that page gets hit with the attack. It's like a digital landmine, just waiting for people to step on. Next, we've got reflected XSS, which is probably the most common one you'll see. Now with this one, the script isn't stored anywhere on the website. Instead, it's hidden inside a URL. This attack needs a little help from you, the victim. The attacker has to trick you into clicking their special link. Maybe they send it in a phishing email or a social media message. When you click that link, the website takes the script from the URL and reflects it right back into your browser, which then, you guessed it, runs the code.
Just look at this example URL here. At a glance, it looks like a normal search on a website, right? But look closer. Tucked right into that search query is a chunk of script. If you were to click on that link, the site might show you a page that says, "Your search results for," and then bam, it would execute that hidden script right there in your browser without you ever knowing.
And that brings us to our third type, DOM-based XSS. This is the really sneaky one. It's so tricky because the entire attack happens right inside your browser. The malicious code never even makes it to the website's server. It works by messing with something called the DOM, the Document Object Model. Think of the DOM as the live blueprint for the web page you're looking at. This kind of attack alters that blueprint as it's loading, which makes it almost invisible to the website's own security.
Okay, we've talked a lot about scripts and servers and DOMs, but let's get to the real question. Why does any of this matter to you? How does this abstract bit of code turn into a real-world risk? Let's connect the dots.
It really comes down to this simple contrast. The website has a perfectly innocent goal, right? It just wants to, say, display a user's comment. But the attacker hijacks that innocent function. They inject a script that does something totally different, something malicious, like stealing your session cookie. And that little cookie, that's the digital key that tells the website, hey, this person is logged in. If an attacker gets that key, they basically become you.
And that's where the consequences get really serious. We're not just talking about some annoying pop-up ad. A successful XSS attack can let a hacker hijack your entire session. They can literally impersonate you. This means they could steal your passwords, read your private messages, get access to your personal data, and in the worst cases, take complete control of your account. It's a huge deal. Which kind of brings us to a big final thought here. What XSS really shows us is just how fragile that chain of trust is that holds the entire web together. It proves that one tiny little coding mistake on a website can spiral into massive consequences for thousands, maybe millions of users. And it really makes you stop and think, doesn't it? If one small oversight can turn a trusted website into a weapon, just how secure is this web we use every single day?